Okay, calculus students, as I'm gone today, I have an answer key for you. And I told you I'd make a video, so here it is. Make sure that you're being quiet so everybody can listen to the video. You should work quietly within groups. This should help you understand what's going on. So there's 3 requirements for a function to be continuous at point A. It starts out, you have to be defined. So if you plug in A to the function, it must exist. You must come up with a value. Second of all, the limit as x approaches A of the function also exists. And third of all, the limit as x approaches A of the function must equal the function defined at that value A. So those are the 3 requirements. Those are things that you have to commit to memory and then be able to perform on the test. So number 2 says identify the points in the interval -4 to 8 where the function is discontinuous, to which these 3 requirements for continuity it fails to meet. If you can't draw it without picking up your pen, so here I got to pick up my pen, plot it there, pick up here, pick up here, pick up here, pick up here. You can see that you have 1, 2, 3, 4, and then at the end there with an open circle, 5 points of discontinuity. I haven't laid out all 5 for you. May not do that on the test. So you can see at -2, at +2, at 4, at 6, and at 8. Now, for -2, if I plug in -2, I get a value. But the limit from this side is positive. The limit from this side is negative. They're different. So it fails because of number 2. The limit does not exist. Same thing for number 2. If I plug in something, I get a value down there. But the limit is positive up here, negative down there. Same thing. The limit does not exist. 4, there is no value. You know, they both head up to infinity, so the limit exists, but you can't plug in 4 and get a function value. So it fails the first requirement. 6, you can plug something in right there. You get a value. But this side is positive, this side is negative for a limit. Those are obviously not the same, so it fails because of requirement 2. And finally, 8, there is no function value. You have an open circle there, so that fails because of the very first requirement. Same thing for number 3. Identify the points on the interval where it is discontinuous. I have to pick up my pencil if I draw it at -8, also at -2, and also at 6. So, as we glance at that, if you try f of -8, you do get a value. You get, on this case, a -3. And the limit exists as I approach from this side, I get -6. As I approach from this side, I get -6. So the limit exists. It's also -6. But as you can see, the limit is not the same as the function value. So therefore, it fails because of the third requirement. So that's a failure by the third requirement right there. -2, you can see that you get an output right there. But the limit is positive infinity on that side. It's 3 over here. So the limit does not exist. It fails because of requirement 2. 6, if you punch in 6, you do get a value. But the limit is 2 over here, whereas it's 5 over here. So the limit does not exist. You watch Mean Girls, you know calculus. There you go. So, second page. Oh, piecewise functions and other stuff. You guys don't like this stuff. It doesn't have to be that difficult. This is my function. You can see it's discontinuous for a equals 1 because you get 0 in the denominator. If you factor the top, you get x plus 1 times x minus 1. This function wants to look like x plus 1. This function wants to look like x plus 1. And that graph looks like this. Except at x equals 1, it has a hole. Some people said, how did you know to put the hole at 1, 2? Well, look, if it wants to look like x plus 1, if I plug in 1 into my function, 1 plus 1 is 2. So I know that that's the case. That's what the graph looks like. It has a hole in it. The question is, what does it fail to meet? It fails to meet the first requirement. F of 1 does not exist. He said, well, Mr. Gens, you said it does exist. No, that's what it wants to look like, except it doesn't. It has a hole right there. You can see it's got a hole, so therefore if I plug in 1, I get nothing by my first function. It's talking about the very first one. Not what it wants to look like, but about the first one. So it fails first requirement. That's what fails. Second one, we got 1 over x squared. 1 over x squared looks like this. It is discontinuous at 0. But the piecewise function fills it in. It says for x equals 0, the function is 1. So it puts a dot right there. So f of 0 equals 1. All right, well, so we passed the first test for continuity. The limit, well, it's infinity on this side, it's infinity on that side, so the limit's infinity. Well, we passed the first two. But is infinity equal to 1? No. So the function defined at a spot does not equal the limit, so therefore it fails the third requirement. Should be able to graph these piecewise functions. X squared minus 4. A lot of people know that's a parabola. Heads up like this. But where do you cut it off? Because it says x less than or equal to 2. Well, you just plug in 2, and you'll find your endpoint. 2 squared is 4 minus 4 is 0. So 2, 0 is my endpoint. So I'm going to scratch that off. 2, 0. Looks like I have a closed circle. Great. Negative x plus 3. You guys all know that's a line that heads down. Let's find my endpoint. I plug in 2, and I get 1. So up over 2, up 1. So I have an open circle there. Slope of negative 1. There's my line. So the question is, we start with f of 2. Does that exist? Yes. Equals 0. Does the limit exist? No, it doesn't. If you come from the right, the limit is 1. If you come from the left, the limit is 0. So the limit does not exist. Therefore, it fails number 2. And the last one, square or absolute value of x over 2. So that's absolute value function, but 1/2 the slope. If you want to know the endpoint, we plug in 4. Square or absolute value of 4 divided by 2 is 2. Open circle. So that's that function. Square root of x. Again, I type in 4, and square root of 4 is 2. Open circle. Looks like it picks up right at that spot. So the question is, that is discontinuous, but why? Well, it fails requirement number 1. F of 4 does not exist. So it fails requirement 1. Write a piecewise function that fills the discontinuity. Where is this discontinuous at? Discontinuous at 2. This one's discontinuous at negative 1. You should know that because you know you can't plug those numbers into the function and get a value. You get 0 in the denominator. But what does this want to look like? It wants to look like x plus 1. So I could say the function is equal to my original one, x squared minus x minus 2 over x minus 2 for x value is not equal to 2. If I want to fill the discontinuity, I have to say when x is equal to 2, I have an output value. Well, if the function wants to look like x plus 1, I can take that 2 value, plug it in there, and I get 3. So the function is equal to 3 for x equals 2. And that fills the discontinuity. All right, letter B. This is a cubic. Doesn't factor the way that you would want it to. But I know that it does divide by x plus 1. How do you divide? Very simple. Synthetic division. 1, 0, 3, 4. Bring down your 1, multiply, add, multiply, add, multiply. X squared minus x plus 4. That's what it wants to look like. So we have x to the third plus 3x plus 4, where x equals, sorry, for x not equal to negative 1. But if we want to fill the discontinuity, we have to put something in for negative 1. What do we put in? Well, again, we look at what the function wants to look like. That's what it wants to look like. And it really does. It looks like that for everything except for one value, negative 1. So if we punch in negative 1, we get negative 1 squared is 1, minus negative 1 is positive 2, plus 4 is 6. Okay, we're halfway done, and video is only 11 minutes. There we go. Flying through. Good thing you guys can pause. Oh, provide a drawing that represents this limit. Excellent. Now, you may think that you know how to do this, but watch this to make sure you got the whole thing, because my guess is that you missed something. There's my function. We'll call it f. I have a point A, which makes that y value f of A. I have A plus H, which makes that f of A plus H. And how do I represent this limit as h goes to 0? What does that mean? Well, you should put in here that the distance between these 2 points is h. So we're drawing h closer to 0. So that green part is something I'm guessing that you maybe left out. And how do we get the formal definition? Well, we just use slope. You know how to do that. We don't need to draw that out. That's sufficient. If I ask you to do this on the test, this is beautiful. This is great. This is how I find instantaneous rate of change at a given point. Something you had no clue how to do till you showed up to this class. Now I can do it easy. And so we do it here. Use this slope definition to find the slope of the equation of the line's tangent at a given point. Slope at one point. Unbelievable. Find our point on our line first. 3. And plug it in. You get 1 over 6. When I find slope, I use the formal definition of the instantaneous rate of change, which is the limit h approaches 0 of 1 over 2 times h plus 3 minus 1 over 6 all over h. Multiply top and bottom by 2 times h plus 3. 2 times h plus 3. Top and bottom by 6. You get the limit is h goes to 0 of, on top I have 6 minus 6 minus 2h all over. On the bottom I have 6 times 2 times h plus 3 all over h over 1. You can see the 6's are going to cancel. Leaves you with a negative 2h. Multiplied by the reciprocal, 1 over h. You can see the 2 and the h will cancel. Leaves you with the limit is h goes to 0 of, in the numerator, I now have a negative 1 over, in the denominator, I now have 6 times h plus 3. I can now plug in 0, and I get negative 1 over 6. That's my slope. Now that I have slope, I need to write an equation for line tangent. So, y equals mx plus b. So y is 1 over 6 equals negative 1 over 6 times 3 plus b. Okay, yeah, you guys saw it. I'm the idiot. Check my answer key. That's right. That should be negative 1/18. I should have said something. There we go. That changes the problem. Knew something was wonky. Okay, so we've got, again, 1 over 6 is equal to negative 1 over 18 times 3 plus b. Or 1 over 6 is equal to negative 1 over 6 plus b, or b is equal to 2 over 6, which is 1/3. So therefore my equation is y equals negative 1 over 18x plus 1/3. Yep. And if you graph this on your calculator, you can see that it does touch tangent. Works out pretty well. Okay, that took up a lot of space. Erase it. Let's try the next one. So if you get this rational expression, some people are like, "Why I don't like it if it comes out to 1 over 2x." Well, you got to remember to combine your fractions then. So, all right, here, point on the line. I have 1, and if I plug in 1, I get 1. So 1, 1. So now I need my slope. Well, slope is equal to the limit as h approaches 0 of 4 times h plus 1, quantity squared, minus 3, and then minus my f of a, which is 1, all over h, which is the limit as h goes to 0 of, let's see, we're going to get 4h squared plus 8h plus 4 minus 4 all over h. You guys can see right here that your 4's cancel. Factor out an h. We get the limit as h goes to 0 of 4h plus 8. Plug it in. Slope is 8. So y equals mx plus b, or 1 equals 8 times 1 plus b. So 7, negative 7 is equal to b. So y equals 8x minus 7. Did I do that right? Yep. So my answer key says. There you go. Graph both of them, see if they touch tangent. Okay, here we've got 7 and we've got 3. 7, 3. Plug in 7, that's our point on our line. Slope equals limit h goes to 0 of square root of. So I'm going to plug h plus 7 into that x. So if I add 2, I just get h plus 9. So h plus 9 minus 3 over h. You guys all know how to solve for that. You got to multiply by the conjugate, multiply by the square root of h plus 9 plus 3 all over square root of h plus 9 plus 3. That works out pretty well. M is equal to the limit. So h approaches 0 of h plus 9 minus 9 over h times the square root of h plus 9 plus 3. 9's cancel. H cancels with the 1 on the bottom, and I'm left with the 1 on the top. Have the limit as h goes to 0 of 1 over the bottom. We have the square root of h plus 9 plus the 3's on the outside of that square root, in case it didn't show up in the drawing. Now I can plug in 0. 0 plus 9 is 9. Square root of that is 3. So I get 1 over 3 plus 3, which is 1 over 6. So my point on my line was 7, 3. So y equals mx plus b. Y is 3. M is 7. I'm sorry, x is 7 times 1, 6 is my slope plus b. 3 or 18 over 6 equals 7 over 6 plus b. So 11 over 6 is equal to b. So y equals 1 over 6x plus 11 over 6. Graph it on your calculator. That's what I do to check to see I'm right, and that is correct. And one more. Trick question, y'all. Think about it. What shape is that if we graph it? It's a line with a slope of -3. So if I run the formal definition all the way through, you know, m equals the limit as h approaches 0 of -3 times, you know, 5 plus h minus 7 minus evaluated at that spot would be -22, so plus 22 over h. Well, look at what I'm solving for. M. I know M. Should get -3. In order to have a line tangent and a line, it's just the same equation, -3x minus 7. So you should get that to work out. Piece of cake. You guys know how to do it. Trick question. Precise definition of a limit. Given a function defined on an interval maybe not at a if the limit as x approaches a of f of x is equal to L, then there exists an epsilon greater than 0 for every delta greater than 0. That must satisfy absolute value of f of x minus L is less than epsilon whenever x minus a is less than delta. That's your precise. That's one form of it. That's kind of how we did it in the song. So you guys should be really good at that. So let's use it. This is f of x. This is L. This is epsilon. I'm looking for delta. Let me get rid of this because it's bad. I want to draw my graph. That's a parabola shifted down 3 units. I draw it like that. Have this be 1. So I'm approaching 2. That's my a value. What I need is an upper bound and a lower bound. Well, if epsilon is 0.1, then 1.1 is the upper bound. I'll need some x value there. Call it x sub 1. 0.9 would be my lower bound. So I need x sub 2 there. I first must find those x values. And I can simply do that by setting my function equal to those values. So x squared minus 3 is equal to 1.1. And x squared minus 3 is equal to 0.9. When you solve, you get x is equal to 2.02 and x is equal to 1.97. So the question is, delta represents how far those are from a is equal to 2. Well, that's easy. 2.02 minus 2 is equal to 0.02. And 2 minus 1.97 is equal to 0.03. So you take the smaller of them, so 0.02. That's how far. So that's this distance right here is 0.02, which is our delta value. So the question is find a number delta. Delta is equal to 0.02. 0.02. I didn't give you room for number 10 to basically be able to set it up. But the whole idea is you need an upper bound and a lower bound. So if your epsilon is 0.2 and the limit is 3, then the upper bound is 3.2 and the lower bound is 2.8. So I set my function equal to that. Square root of x plus 8 is equal to that. And I'm trying to come up with x values. Square both sides and add the result, and you get x is equal to 2.24 and x is equal to negative 0.16. What is our a value? What are we approaching? We're approaching 1. So how far are we from 1? Well, 2.24 minus 1 is 1.24. And 1 minus negative 0.16 is equal to 1.16. That's the lower of them, so delta is equal to 1.16. Now, if you're mad because I put 1 in front, 1 in back, it doesn't matter. The value's got to become positive. Remember, the formal definition or the precise definition says we take the absolute value. That's the distance that they are. So if you come up with a negative number in the end, you just make it positive. It's the distance. So it's really just the absolute value. So if you'd rather I do, negative 0.16 minus 1, well, again, it's the absolute value of that, which is still 1.16. So keep that in mind. Okay, last problem, prove. So prove that the limit as x approaches 2 of 3x plus 7 is equal to 13. You know that that's true because you can use substitution. But we must use the precise definition of the limit. So we will. First step is to choose delta. So we know that f of x, which is 3x plus 7, minus the limit, which is 13, must be less than epsilon whenever x minus, what is my a value? It is 2, is less than delta. So we're trying to find a delta that will satisfy that for every epsilon. Well, I just play with this equation. I get 3x minus 6 is less than epsilon. I get 3 times x minus 2 is less than epsilon. So I get x minus 2 is less than epsilon over 3. So it says choose delta. Delta is equal to epsilon over 3. So we found our epsilon that we should choose. Now the second part is to let delta equal epsilon over 3. Show that the absolute value of f of x minus L is less than epsilon whenever x minus a is less than delta. So I got to do that. So the absolute value of f of x, so 3x plus 7 minus my limit, which is 13. That's the same thing as 3 times x minus 6, which is equal to 3 times x minus 2. Whoa, that x minus 2, where did that come from? We know where the x minus 2 came from. Right here. X minus 2 is less than delta. So 3 times x minus 2 must be less than 3 delta. What is delta? Delta is epsilon over 3. Well, 3 times delta is equal to 3 times epsilon over 3, which is equal to epsilon. So, we did it. We took the function minus the limit. We set it less than our epsilon. So our equation holds true. That is satisfactory. We've just proven it. There's my video. About half an hour. I guess you have some time to work. Good luck. I hope it goes well. You got a lot of stuff to use.